Hello YouTube, this is Jay Coda here, and I'm back with another stream. And today we're going to be continuing with the code lab that we were going over yesterday, where it was all about Viewmodel. And so we started with starter code, a game app that we had a game app they had us download that was a scramble word application. And so we're adding a view model to that. And so we're going to be continuing from where we left off. And so please subscribe to the channel. And if you like this kind of stuff and like this video, give a comment. And let's go ahead and get started. And so I'm happy you all are here. This is a very key concept to Android development, view models. And so also I'm going to go ahead and post this code lab into the chat so that everyone that joins the chat can be able to follow along with us. So, and also there was some starter code that we need to download as well. Let me retrieve that for you here. And so I'm going to go ahead and post the starter code in the chat as well, in case someone wants to go ahead and download that starter code to be able to follow along as well. So that is the starter code for this lab. Alright, and so basically what we were doing is yesterday we were adding the view model, and so and so this is an important step that we left off from yesterday. It says delete the code inside the method on submit word and on skip word. And I already have the code here inside my Android Studio copy. And so basically what we were doing is inside the game fragment, we were going ahead and deleting this implementation, because what we did was we added the variables to the view model instead of accessing the variables from the game fragment. And so we need to implement this differently later on in the lab as we follow along. And they also told us to keep in mind that never expose mutable data fields from your view model. Make sure the data can't be modified from another class. Mutable data inside the view model should always be private. So that means they do not want us to be able to change the values directly from the actual fragment, but it should only be changed within the actual view model class. And then also we went over this part as well, and so they had us put some logging inside the onCreate function for the game fragment, and also inside the on, and they made us make an override. We are overriding this built-in method inside the game fragment to add some logging there as well. And in addition to that, we have an onClear method that is inside the game view model that we are logging as well. And also, in addition to that, we're logging when the view model is created. So basically, now that we have that, they wanted us to basically check to see here when things are created. They wanted us to go ahead and run the application. So in Android Studio, run the app, open the logcat, and filter on game fragment. Notice that game fragment and the game view model are created. So, all right, let's go ahead and go to our Android Studio, and then we're going to go ahead and run it. And then after we run it, we're going to go ahead and go, at this point, go to our logcat. And then we're going to filter by what they said, the game fragment, which we enter the game fragment into the search. Then we have this tag game fragment here. And we notice that the game fragments created was made, and then the game view model was created after the fragment was created. So that's what we had there. And then it says enable the auto rotate setting on your device or emulator and change the screen orientation a few times. The game fragment is destroyed and recreated each time, but the game view model is created only once and is not recreated or destroyed for each call. So we're going to go ahead and take our emulator, and then we're going to go ahead and rotate it. And then, all right, so let's see here. Okay, we're gonna rotate it. Let me see. The settings. Do we have inside the settings? What do we have here? Inside the settings. Auto rotate is on. Let's go back. Let's do that again. For some reason, it's not wanting to rotate. Let me see. So, let me go ahead and put out. And I'm going to go ahead and go to my Android Studio. Then I'm going to go ahead and run it again. And then after I run it, and then I'm going to check my settings. Okay, so my settings, auto rotate is on. So I'm going to go back to my home. And then looks like it's played. Gonna go to my what is this? This is the actually, let me go ahead and just play it real quick. Gonna Then after I play it, let me rotate. Alright, it has rotated. And now, since it has rotated, let us go to the log cat. And then inside the log cat, let's see, it did the fragment and the view model. Let's see, once I rotate it back, okay, I rotated it back. Where's my logging? Okay, so it somehow disconnected from my logging right there, so I connected it here. And then, so, alright, so there, what it wanted us to see is, well, this was from the last run, but when you run it, it will create the fragment and then create the view model. But no matter how many times you rotate it, it will destroy the fragment, but will not destroy the view model unless you close the app completely. So see, the view model is still not created or destroyed, and that's what they wanted us to see in this example. Alright, let us go back. It says exit the game or navigate out of the app using the back arrow. The game view model is destroyed, and the callback on cleared is called the game fragment is destroyed. Alright, let's see if we can go ahead and destroy this application. Go ahead and hit the square. Then I'm going to close it like that. So it should be closed. And then I go back to my Android Studio and we go back to our Android Studio and I do not see a call from the game view model. Let us try that again. Let me go ahead and go back to the unscramble application. A new process has been started. The view model has been created. And then let me try that again. I'm going to go ahead and hit that and close this. Alright, and it says process ended. However, since the process ended, okay, let me try this then. Let me go ahead and play it again. And then once I play it again, I'm going to go ahead and let's go to our logcat. Then there is a new process started. Then I'm gonna go ahead and hit the back button. Okay, so let me see something here. Did I add to the view model the uncleared method? So I did add the uncleared method. And then once I added the uncleared method here, to add it to the correct place. So it's inside the view model. And then let's go back to the lesson. And yeah, that's under the game fragment. It should be. And it should say destroyed. And then let me see. Let me go back to this and exit the game or navigate out of the app using the back arrow. So using the back arrow and exiting did not seem to call our clear method, but I mean, if we can't exactly see that, it's not that important. Just so we know, they're trying to make the point that the view model is destroyed when you close the app. So what if I just play this? Okay, we have in the log cat this process. Okay. And then what if I just stop it? Process ended. So for whatever reason, it doesn't want to call the uncleared before the process ends, because it keeps ending the process before calling this. But I mean, we get the point that the view model is destroyed, so let us just go on. Next, let's see. Okay. In this task, you further populate the game view model with helper methods for getting the next word, validating the player's word to increase the score, and checking the word count to end the game. Late initialization. Typically, when you declare a variable, you provide it with an initial value up front. However, if you're not ready to assign a value yet, you could initialize it later. To late initialize a property in Kotlin, you use the keyword late init, which means late initialization. If you guarantee that you will initialize the property before using it, you can declare the property with late init. Memory is not allocated to the variable until it is initialized. If you try to access the variable before initializing it, the app will crash. Get next word. Create the get next word method in the game view model class with the following functionality. Get random word from all words list and assign it to current word. Create a scrambled word by scrambling the letters in the current word and assign it to the current scrambled word. Handle the case where the scrambled word is the same as the unscrambled word. Make sure you don't show the same word twice during the game. Implement the following steps in game view model class. 1. In game view model class, add a new class variable of type mutable list string called word list to hold a list of words you use in the game to avoid repetitions. add another class called current word to hold the word the player is trying to unscramble. Use the late init keyword once you will initialize this properly later. So inside our game view model, we will declare two new class variables. So they want us to go to our Android Studio and go to our game view model. And then inside our game view model, we're going to declare two new variables, which is going to be private var word list, which is a mutable list, and current word. All right. Add a new private method called getNextWord above the init block with no parameters that returns nothing. Get a random word from the all words list and assign it to current word. So we're going to create this method above the init block, and then the init block is right here, and we're going to go ahead and make a new method here, get next word, and then the current word is going to be assigned to a random word from the full word all word list. Now what it wants us to do is in get next word, convert the current word string to an array of characters and assign it to a new val called temp word. To scramble the word, shuffle characters in this array using the Kotlin method shuffle. So in the get next word, convert the current word string to an array and assign it to a new val called temp word. So inside our get word next, we're going to go to our Android Studio. Then inside our get word next, we're going to go and here, and then inside our get word next, we're going to go in there, and now, yeah, so we assign the temp word to an array, and then we shuffle. Alright. An array is similar to a mutable list, but it has a fixed size when it's initialized. An array cannot expand or shrink the size. You need to copy an array to resize it, whereas a mutable list has add and remove functions so that it can increase and decrease in size. Sometimes the shuffle order of characters is the same as the original word. Add the following while loop around the call to shuffle to continue the loop until the scrambled word is not the same as the original. So we're going to add a loop to it in order to not get the same word twice. And we probably need to delete that. Add an if-else statement block to check if a word has been used already. If the word list contains current word, call the get next word. If not, update the value of current scrambled word with the newly scrambled word. Increase the word count and add the new word to the word list. So we add this code here and we add it after we check this while loop here. And then here is where we check if the word list contains current word. If we already used that word in the game, then do this. And so let me just make sure everything is correct there by getting this code here and putting it inside the get next word. All right. And so the current word count plus. Now you have created the get next method. To get the next scramble word, you will make a call to when the game view model is initialized for the first time. Use the init block to initialize late init properties in the class, such as the current word. The result will be that the first word displayed on the screen will be scrambled, a scrambled word instead of a test. Run the app. Notice the first word is always test. To display a scrambled word at the start of the app, you need to call the get next word method, which in turn updates the current scrambled word. Make a call to method get next word inside the init block of the game view model. Now, let me just take a look at something just really quick. So, current word is giving us trouble being added. And we have current word here as a late init var. And so, current word says cannot be val cannot be assigned. So why are they saying val? Do I have it here? So okay, so this one does not need to be declared in this way, just needs to be declared in this way, because outside the function, it's not going to need to be accessed outside the function. So we're going to outside the view model. So we do it in that way and declare it in that way. And so I was just saying variable expected undefined reference current um, current scrambled word, current word count. Let me go ahead and current word counts. Current word count. Current word counts. Current word count. So we declare it like this. And then that corrected our error right there, so that we can successfully increment this method or this word, which it cannot be accessed outside the view model because it's declared private. And then we have the get next word method implemented now. So we have all the code we need for the get next word method. Now, late initialize current scramble word. Now you have created the get next word method to get the next scrambled word. You will make a call to it when the game view model is initialized for the first time. Use the init block to initialize late init properties in the class, such as the current word. The result will be that the first word displayed on the screen will be a scramble word instead of test. Run the app and notice the first word is always test. To display a scramble word at the start of your app, you need to call the getNextWord method, which in turn updates current scrambled word. Make a call to the method getNextWord inside the init block. So we're going to go ahead and call our getNextWord method inside the init block so that we can be able to so they can start to play the game without seeing the test message. So we take that and put it inside our init block. So we're searching for our init block, and then this is our init block, and then inside our init block we're going to call get next word. Alright, so we're calling the get next word here. And then it says add late init modifier onto the current scramble word property and add an explicit mention in the data type string since no initial value is provided. So we're going to use late init for the current scrambled word. Late init means we're not going to initialize it right away, but we're going to make a promise that we will initialize it later. So basically, current scrambled word is going to be declared like this, which is going to be initialized later. Late init, we're not going to initialize it now to a value, but we promise to initialize it later. And where do we initialize it later? We initialize it inside our get next word which this is where we initialize it. And so we will call the get next word in order to be able to initialize it. All right, now it says to go ahead and run the app, and notice a new scramble word is displayed. All right, so when we go ahead and run it, let's see what happens. And okay, it's a compile issue. Resolve reference. View model dot current scrambled word. So current. Let me see. So this is inside our game fragment. Inside our game view model, we have this as a latent int, but we're going to probably also still need to initialize it so that it can be accessed outside the class. So like that, so that it can be accessed outside the class. And this line needs to be, let me see. So violated of our current scrambled word. So instead of assigning it equal to test, we're going to assign it as a late init. And we're not going to delete this because we have to access it outside of the view model, which is game fragment. Let's check if that works here. When I hit play, alright, it has successfully launched. And so, well, just to see it, let's see. The app is launched. Boom. There's a random word, and it's no longer saying test. Great. So we have done what it has told us so far. And all right, says add a helper method. Next, add a helper method to process and modify the data inside the view model. You will use the method in later task. In the game view model class, add another method called next word. Get the next word from the list and return true. If the word count is less than max, no of words, the max number of words. So it says inside the game view model, we are going to add this method. So inside the game view model, let's go ahead and add that. So we are in the game Viewmodel now. I'm gonna go ahead and add that method here. And that method is the next word. Or, yeah. Actually, let me go ahead and add that after the get next word. Alright, next word. Alright, then it says, so we did that. Okay, says 8 dialogues. Let me see. So it says here back. Okay, so we will use this method in later tasks, trying to figure out where they are using this method, but they said they're going to use it in a later task. Alright, going on. In the starter code, the game never ended, even after 10 words were played through. Modify your app so that after the user goes through 10 words, the game is over and you show a dialogue with the final score. You will also give the user an option to play again or exit the game. This is the first time you'll be adding a dialogue to an app. A dialogue is a small window screen that prompts the user to make a decision or enter additional information. Normally, a dialogue does not fill the entire screen, and it requires users to take an action before they can proceed. Android provides different types of dialogues. In this collab, you will learn about alert dialogues. So, anatomy of an alert dialogue. 1. Alert dialogue. 2. Title optional. 3. Message. 4. Text buttons. Implement the final score dialogue. Use the material alert dialog from the material design components library to add a dialog to your app that follows material guidelines. Since the dialog is UI related, the game fragment will be responsible for creating and showing the final score dialog. First, add a backing property to the score variable in game view model. Change the score variable declaration to the following: private var score. So we're gonna first add a backing property to the score variable in the view model. Change the score variable declaration to look like this. So inside our Android Studio, we're going to go to our score, and basically we're not using the score yet. However, I already modified it to look like that, so it's already ready for use. In-game fragment, add a private function called show final score dialog to create a material alert dialog. Use the material alert dialog builder class to build up parts of the dialog step by step. Call the material alert dialog builder constructor, passing the content using the fragments require context method. The require context method returns a non-null context. Creates and shows an alert dialog with the final score. As the name suggests, context refers to the context of the current state of the application, activity, or fragment. It contains the information regarding the activity, fragment, or application. Usually it is used to get access to resources, databases, and other system services. In this step, you pass the fragment context to create the alert dialog. If prompted by Android Studio, import the required dependency. Okay, so we will add this method to our fragment. So we go to our Android Studio, and then inside our Android Studio, inside our fragment, we will add another method here, and it's going to be the show final score dialog. We're going to go ahead and import that, and so we have that there. And so the reason why we show the dialogue in the fragment is because, remember, the fragment deals with the UI, and it has the authority to update the UI. However, we should not, best practices say we should not update the UI from within the game view model. So we need to keep that logic separate. So that's why we are showing the final score dialog box inside the fragment, because that's related to UI. As the name suggests, context refers to the context or the current state of an application, activity, or fragment. It contains the information regarding the activity, fragment, or application. Usually it is used to get access to resources, databases, and other system services. In this step, you pass the fragment context to create the alert dialog. If prompted by Android Studio, and then import this, and then add the code to set the title on the alert dialog. Use a string resource from the strings.xml. Okay, so we're going to set the title to a string resource called congratulations, which is probably already pre-built inside our starter code here. So we're going to go back to our Android Studio, and then we're going to add that there. And so that's setting the title of the dialog to congratulations. Set the message to the final score. Use the read-only version of the score variable, viewmodal.score, you added earlier. So we need to retrieve the score from the view model. In order to retrieve the score from the view model, we retrieve the read-only score by using the dot notation. So okay, actually we're copying this whole thing right here, and we're going to be adding that next. after that, which is set message, get string, and your score is going to be the actual score that's being kept track of inside the view model. So, all right. And make your alert dialog not cancelable when the back key is pressed using set cancelable method and passing false. So we need to also have this for safety measures so that the user will not hit the back button and glitch out of the dialog. Okay. And then it says add two buttons, exit and play again using the methods set negative button and set positive button. Call exit game and restart game respectively from the lambdas. So with the lambdas, you see that they're using this arrow notation. Whenever you hear lambda, you're going to see the arrows. So inside our dialog builder, we're going to add these two methods, which is exit game and restart game. These methods are already implemented, it looks like. I'm going to go ahead and close this. It says, this syntax may be new to you, but this is shorthand for this code where the set negative button method takes in two parameters, a string and a function. Dialog interface dot onClick listener, which can be expressed as a lambda when the last argument being passed in is a function. You could place the lambda expression outside the parentheses. This is known as trailing lambda syntax. Both ways of writing the code with the lambda inside or outside the parentheses is acceptable. The same applies for the set positive button function. At the end, add show, which creates and then displays the alert dialog. And then, so we are going to go ahead and show that after we have done all of this. All right. And then here is the complete show final score dialog method for reference. So we have this complete thing for our reference, and it says implement on click listener for submit button. So in this task, you use the view model and alert dialog you added to implement the game logic for the submit button. Display the scrambled words. If you haven't already done so, in game fragment, delete the code inside on submit word, which gets called when the submit button is tapped. Add a check on the return value of viewmodal.nextWord method. If true, another word is available, so update the scrambled word on screen using update next word on screen. Otherwise, the game is over, so display the dialog with the final score. So inside the on submit word, we're going to add this code. And this is where we actually finally use this method, the next word. So we get the next word, or we show the final score. Alright, and now let's go back to our Android Studio. And then we're going to go to our on submit word. And then inside our on submit word, we are going to replace the previous code with this. And now our view model handles the logic of adding to the score and managing the score. And so we have that now. And now it says run the app. Play through some words. Remember, you have not yet implemented the skip button, so you can't skip the word. Notice the text field is not updated, so the player has to manually delete the previous word. The final score in the alert dialog is always 0. You will fix these bugs in the coming steps. So let us go ahead and play it and see what we have so far. When we go to our Android Studio, then we're going to go ahead and play it. And then when we play it, we're going to play through. So, unscrambled word. What is that? Free. Okay. Submit. And what is that? Kind. Submit. See. That is, well, what if I put anything? Alright, we played through the words. And it says, congratulations. You scored 0. And then play again or exit. Okay, play again. Takes us back here. Let me see. And then, or you can exit, which exits the game. Alright. Now, let me see. It also does not update the score and word number, the words yet. And so add a helper method to validate player word inside the view model. Add a new private method called increase score with no parameters and add no return value and increase the score variable by score increase. So we're going to copy this code, and we're going to this time go to our game view model, and then inside our game view model gonna go and we are going to inside our game view model. Let's see. I'm gonna add that method. So somewhere in there, I'm gonna go ahead and add it. We can do this after this next word method. All right. So that's going to increase the score. In-game view model, add a helper method called isUserWordCorrect, which returns a boolean and takes a string the player's word as a parameter. In isUserWordCorrect, validate the player's word and increase the score if the guess is correct. This will update the final score in your alert dialog. So we're going to also add this to our check if the word is correct, instead of the game just letting you go on with any word. And so I'm going to go ahead and add this to here. So is user word correct if the player word equals current word, then increase score, return true, else false, return false. So update the text field. Show errors in text field. For the material text field, text input layout comes with the built-in functionality to display error messages. For example, in the following text field, the color of the label is changed, an error icon is displayed, an error message is displayed, and so on. To show an error in the text field, you can set the error message either dynamically in code or statically in the layout file. Examples to set and reset the error in the code is shown below. Set error text. Player error text. In the starter code, you will find the helper method set error text field is already defined to help you set and reset the error in the text field. Call this method with true or false as the input parameter based on whether you want an error to show up in the text field or not. Code snippet in the starter code. So we have this code snippet. If error, then do this. Else, then do this. And in this task, you implement the method on submit word when a word is submitted. Validate the user's guess by checking against the original word. If the word is correct, then go to the next word or show the dialog if the game has ended. If the word is incorrect, show an error on the text field and stay on the correct word. And game fragment at the beginning of the on submit word, create a file called player word. Store the player's word in it by extracting it from the text field in the binding variable. So inside the onSubmit word, we're going to do this. So onSubmit word inside our game fragment, we are going to add this binding.text input this on the top of our method. Alright, so we're going to add that to the top of our method there. Alright, so I'm going to go ahead and end this stream for today. And I'm going to continue with the part 3 tomorrow, because this is a pretty extensive code lab, and we're working on more of a complicated application with more functionality that we are going over bit by bit, just so that you all can understand and that we don't really skip anything. And so I'm going to say, please come back for the next stream, and we will continue this application, and I'm pretty sure we'll be wrapping it up next time. And so we're going over Viewmodel, guys, and I hope that you guys are learning something, because Viewmodel is a very, very important concept in Android. And basically, Viewmodel should be used in every application that you make in Android, because it's common practice, because you want to separate the concerns of the view model from the UI, which the things that deal with the UI are the fragment and the activity. And you shouldn't, in the activity, do the job of the view model, which the view model is to be able to manipulate the data and then store the data for you in case the fragment is destroyed. The data will not be lost. The data will persist inside the view model while in memory, such as if you change the orientation, that destroys the actual that destroys the actual fragment or the activity. And so one key reason we have the view model is so that we can store things like the score and not lose the score to being erased if the device is rotated. So, alright, and hope you guys learned something, and I encourage you guys to, as always, stay coding, and I'll see you all next time. Peace.